All right, boys and girls, welcome back to the drive-through. Hope everyone's off to a good start this week. This is your 3.3 lecture on CPCTC and circles. Okay, CPCTC is one of the most important theorems that we'll use. We'll use it for the rest of the year. You have to understand what all the letters stand for because kids just make it up. It stands for corresponding parts of congruent triangles are congruent to each other. Okay? What the heck does that mean? Well, if within your proof you were able to prove that triangle dog was congruent to triangle cat, well, now you know that there are 6 pieces of congruent parts. So you know that the corresponding angle D corresponds with angle C because order matters. And you know that angle O is congruent to angle A, and you know that angle G is congruent to angle T. You also know that DO is congruent to CA, that DG is congruent to CT, and that OG is congruent to AT. Okay? So that's what that says. If you are able to prove that 2 triangles are congruent, now we are able to pull out all of the pieces and say that the corresponding parts are also congruent. And our reason will be CPCTC. So the first thing you'll do is prove the triangle is congruent. This is how we prove triangles congruent. These are our reasons. And then you will pull out the additional information and list CPCTC as your reason. Don't worry, we'll do some examples, okay? There's another new theorem here, and that says that within a circle, all radii are congruent to each other. So you are given that this is circle H. Sometimes it'll say given circle, actually it'll look like this. That means that H is the center of the circle. Now we know that HI and HA are radii because H is the center. So you could say that hi is congruent to ha, and your reason would be all, this is one of my favorite words, radii are congruent in a single circle. Doesn't mean every radii in the whole world is congruent, but every radii within the same circle is congruent. All right, so let's just take one look at a tough problem. So here's our only example problem for the day. And you can see that these proofs are really starting to get real. So we are given that T is complementary to O, that one there, to MOT. And we are given that S is complementary to POS. We are also given that it is circle O, which means O is the center of the circle. That's all we're given. And we are asked to prove that this part is congruent to this part. So with very little information given, we've got to prove that 2 segments are congruent to each other. All right, look, what you want to do is start working backwards on this. So, how could I prove that these 2 parts are congruent to each other? Well, I could prove that the triangles are congruent to each other. And if the triangles are congruent to each other, then their parts will be congruent by CPCTC. Okay, well, how could I prove the triangles are congruent to each other? Well, I know that OT and OS are radii, so they're congruent to each other. Okay? I also know that these angles are congruent to each other because they're vertical. Ooh, and then I'm going to be able to use congruent complements. And I think this is going to be an ASA proof, and then CPCTC. So I have just done the proof in my head before I even started. That's the key as you move forward to doing these. You got to solve them backwards before you get started, and then rewrite them forwards. So I'll say angle T is comp to angle mot, and angle S is complementary, okay, to this POS here. And I know that we have circle O. All that tells us is that O is the center of the circle, so we're going to be able to assume that OT and OS are radii. Okay, that is all given. All right, so step 2, I'm going to say that OT is congruent to OS. Maybe you would do that in a different order. The order doesn't always matter as long as you don't skip any steps. So that's going to be all radii of a circle are congruent to each other. Now I'm going to mark that. And I'm going to write here in a little different color, we have an S. We just did an S. Okay? All right, now I'm going to say that angle TOM is congruent to angle SOP. And what allows me to say that is that vertical angles are congruent. Okay? Well, now I have an angle. So, since angle T is complementary to this, and angle S is complementary to that, but this and that are the same thing, hopefully you guys are getting good at recognizing the fact that if two angles are complementary to the same angle, then those two angles are congruent to each other. So I can say angle T is congruent to angle S, and my reason will be the congruent complements theorem. Let's mark it, and let's write that I just figured out that was an angle. And we'll say that, mark it with 2. So look, you can see on our picture now that we have an A, and an S that's in between. That is the ASA postulate. So now I can say, that triangle TOM is congruent to triangle. Now I got to make sure I write this down in order. TOMSOP, to triangle SOP, and my reason is the ASA postulate. Okay? And finally, this is where the new section comes in. So now I can say that MO, see this, MO and PO? MO is congruent to PO because corresponding parts of congruent triangles are congruent. Boom!